Hello students, how are you everyone? So welcome to the Physics Pathsala. Students, today we are here to learn a very interesting topic called as circular motion. Now what is circular motion? So you know that whenever a particle moves along the circumference of a circle, then that motion will be regarded as circular motion. A very simple example. Suppose, for example, if I am having an object and if I tie that object with a string and I start drilling it, so what will happen? The object is going to move along the circumference of a circle. So, a motion in which particle moves along the circumference of a circle, that will be regarded as a circular motion. A best example for a circular motion is motion of planet. You know that every planet moves in a circular orbit around the sun. And it is also true for the motion of electron. So you know that every electrons move around the nucleus in a circular orbit called as radius, or in a circular orbit the electrons moves around the nucleus. So this is something about the circular motion. Moving ahead. So in circular motion, the next topic is angular displacement. Now what is angular displacement? So you have already learned that in case of linear displacement, where a shortest path will be called as linear displacement. So in case of circular motion, the angular displacement is the angle traced by the radius vector. So whatever will be the angle traced by the radius vector at the center, that will be called as angular displacement. And it is given by formula theta is equals to arc upon radius. And the unit for angular displacement will be radian. And you will be amazed to know that it does not have any dimension. So angular displacement is a dimensionless quantity. Moving ahead. After angular displacement, the next topic comes is the angular velocity. So as student, we saw that in case of angular displacement, the radius was tracing an angle at the center. So when we talk about angular displacement, we can say that the rate of change of angular displacement will be called as angular velocity. So what we can do that? And even we can say that this angular velocity will be represented by omega, and omega can be written as d theta by dt. So this d theta by dt, in this case we write limit t tending to 0, and this limit t tending to 0 means that it is very small. And even this can also be written as omega equals to theta 2 minus theta 1 upon t. And the unit for angular velocity is radian per second. And the dimension for angular velocity will be m0 L0 t minus 1. So after angular velocity, the next topic is angular acceleration. So as we say that the rate of change of angular displacement is angular velocity, in the same way we can say that the rate of change of angular velocity will be called as angular acceleration. So in case of angular displacement, we said that angle traced by the radius vector. In case of velocity, we say that the rate of change of angular displacement. In case of acceleration, we'll say that the rate of change of angular velocity. So I hope till here it is understood. And angular acceleration will be represented by alpha. So we can say that alpha equals to, again, limit t tending to 0 d omega by dt. And it could be also written as alpha equals to omega minus omega naught upon t2 minus t. And the unit for angular acceleration will be radian per second square. And the dimension will be m0 L0 t minus 2. So I hope till here you understood. So the remaining will continue in the next class. Till then, bye and take care.